हाँ।
प्रॉब्लम बचता सॉफ्टवेयर number one, define velocity. Again, the first statement gives you the overall idea of what the whole question is going to be about. So if it's velocity, so it's most probably going to be about kinematics. Question number one. Velocity is basically, uh, we know that velocity is displacement over time. So from over here, you can say that velocity is basically the rate of change of displacement. You can derive all the definitions using formulas, especially those which have time in it. Basically have a similar definition. Rate of change of displacement or change in displacement, which is change in S over time. A rock of mass 7.5 kg is projected vertically upwards from the surface of a planet. The rock leaves the surface of the planet with a speed of 4 meters per second at time t is equals to 0. The variation with time t of the velocity of the rock v is shown. Assume that the planet does not have an atmosphere. So basically there is no air resistance since there is no air. And then the viscous force acting on the rock is always 0. This is also related to air and drag and stuff. Determine the height of the rock above the surface of the planet at time t is equal to 4 seconds. Okay, so basically this is, you can like almost estimate the difficulty of the question from the marks. 3 marks, so it's not going to be that very simple. So we know that velocity is basically what's happening over here is the rock. This is the rock and this is planet, let's say it's Mars or something. It's projected vertically. It's 4 meters per second. So as it goes upwards, it has an acceleration downwards due to gravity, which is different than 9.81 since it's another planet. So um, as it moves, its velocity decreases since it's accelerating downwards. So it's going to be something like this, and at its maximum height, it's going to have a zero velocity, and then it's going to come back. If you just similarly, if you throw a rock in this planet on Earth, that's what you get. So it says determine the height of the rock above the surface of the planet at time t is equal to 4 seconds. So if you can see here, it travels until 2.5 until its speed is 0. So that means at maximum velocity, the maximum height to reach it takes 2.5 seconds. And after that, 1.5 it comes down. So we know that the displacement is basically the area under the graph, this thing over here. So this displacement is what it's traveled upwards, and this is what it traveled downwards. So we to find the height at planet at time is equal to 4. Like at this point, we will subtract this height from this height. Figure that out, Java. So the height of traveling upwards half into, since it's a triangle, 4 into 2.5 minus this height half into how much is this? You know that one small square is 0.2, so negative 2, 2.2, 2.468. So it's basically 2.4. You can ignore the sign over here. We don't need the sign. Into this is 1.5 So the height at that point is basically 3.2 meters. Understand? Okay. Determine the change in the momentum of the rock from time t is equal to 0 to time t is equal to 4 seconds. Change in momentum, you can say it's final momentum minus initial momentum. So at t is equal to 4 seconds, it has a velocity of 2.4, negative 2.4 meters per second. And we know that momentum is basically uh, mass into velocity. Final momentum will take the uh, downward direction as negative. So final momentum is mass, which is 7.5 kg into negative 2.4. And then minus initial momentum, which is 7.5 into 4. So we get 7.5, take that common, and negative 2.4 minus 4. So we get 48 Newton second. Basically, it's 48 Newton second, but since it's asking for change, we're saying it's Newton second since it's basically force into time. That's the that's the units of momentum is that resultant force is equal to change in momentum over time. The change in momentum is basically force into time. That's where it gets its units from Newton second. Since they're asking for change, we can write 48 only. We don't need to write the negative sign. If you write it, it's not a problem, hopefully, inshallah. Determine the weight W of the rock on this planet. To find the weight, need to know uh, basically um, there is when the rock is projected upwards, it has a resultant force acting downwards, right? Which causes the downward acceleration. So that resultant force is basically its weight. So basically, the force, or you can like substitute it with the weight. It's from over here. It's basically the same force, right? It's only the weight is acting on the rock, no other force. So weight is basically change momentum over time, right? So you can say 48 over 4, get 12. In practice, the planet in part B does have an atmosphere that causes a vicious force to act on the moving rock. State and explain the variation, if any, in the resultant force acting on the rock as it moves vertically upwards. So basically, since it's projected upwards with the speed, vicious force, you can take that as air resistance, which is force to drag, similar things. So if you see what it's since it's projected with some speed, there will be like big air resistance initially, but as speed decreases, so the air resistance decreases. But initially, it will have a very high air resistance. So they've asked for in the resultant force acting on the rock as it moves vertically upwards. So initially, the resultant force is very high. So you see, like previously, we didn't take resultant force into account, but we're taking over here since it like changes the rules. Oh, yeah, just said okay, though now there is an atmosphere. So the resultant force over here will be weight plus the vicious force, right? So vicious force is basically proportional to speed, since we can check that as acceleration. So uh, uh as the speed is decreasing, the vicious force is also decreasing. So the total resultant force will also decrease, right? Since it's basically weight plus vicious force. And as viscous force is decreasing, since the speed is decreasing, like if we say speed is basically proportion to resultant force, right? Air resistance, viscous force. So speed decreases, viscous force decreases. So the total resultant force, it also decreases. So we can say that it also explains the variation. Resultant force decreases as viscous force decreases, since velocity, or you can write speed as well, decreases. State what is meant by the center of gravity of an object. Center of gravity is basically where uh, the with the a point where the weight of the object is acting. So it's basically point, like we take it to act, but the weight acts equally, but it's a point which we take to act. All the weight of an object taken to act. A non-uniform rod XY is pivoted at point P. The rod has length 4 meter and weight 44 Newton. Center of gravity of the rod is 1.7 meter. From the end X of the rod, point P is 1.1 meter. From end X, a sphere hangs by a wire from end Y of the rod. Weight of the sphere is 3 Newton. Weight of the wire is negligible. Okay. Force F is applied vertically downwards at X so that the horizontal rod is in equilibrium. By taking moments about P, calculate F. See, this is like this type of question. Moments which you can get. We know that clockwise moment is equal to anti-clockwise moment. So we know that the only anti-clockwise moment which we have is F into perpendicular distance, which is 1.1. The clockwise moments, the weight of the rod T4 to perpendicular distance from the pivot, which is this over here, 1.7 minus 1.1, which is basically 0.6, right? And 0.6 plus 3 into 4 minus 1.7, which is 2.3. So F you get, oh sorry, not 1.7, 4 minus 1.1. My bad. So basically F, what you get F is 32. Calculate the force exerted on the rod by the pivot. This force right here. Uh, so that um, basically, if you like take this as a single object and you say it's like since it's positioned over here, the total force it's applying on this pivot is basically the sum total of all these forces, right? So you can say, and since the force it the rod applies, it will apply, the pivot will apply it again. Since there is no like vertical movement, so this will impose a zero. So you can say 34 plus 44, F plus this plus 3 gets 79. The sphere in B is now immersed in a liquid in a container as shown. Density of the liquid is 1100 kg per meter cube. The upthrust acting on the sphere due to the liquid is 2.5 Newton. Magnitude of F is unchanged so that the horizontal rod is not in equilibrium. Use Archimedes principle to determine the radius of this R of the sphere. Basically, Archimedes principle is basically upthrust, the formula of upthrust rho GV. Like he proves how an object, if in like the upthrust are acting on the object is basically equal to the lens density into gravity into its volume. That's essentially what the Archimedes principle is. And it's a fancy text. It's said that to confuse hopefully. So the upthrust is 2.5. So 2.5 is equal to density. They've given us 700 into gravity 9.81 into volume. If we can find the volume, we can find the radius. The volume we get is 2.32 to 10 power negative 4 meter cube. And we know that volume is basically 4 over 3 pi r cube. So r becomes 2.32 to 10 power negative 4 into 3 over 4 divided by pi cube root. So r is basically 0.038 meters. Calculate the magnitude and direction of the resultant moment of the forces on the rod about B. So the distances are the same, right? So we know that uh, it was three down here, but now it's going to control this. So it's basically, we can estimate it's going to move in the clockwise, anti-clockwise direction. So calculate the magnitude. If it doesn't, it just the answer will just be a negative. So we can figure that out anyway. But that's what we're gonna assume. F was 44. Sorry, F is 32 into 1.1 moment of F minus the moments of the clockwise forces 44 into 0.6. And we know now that so basically the sphere, it has weight and it has an upthrust. So they basically both acting in opposite directions. So that will like add up to give us the resultant, which will be since it has it still has its weight. So the only additional force right now is this upthrust acting, right? So even if we like take the moment of this force, that will be the resultant moment. So we really don't need to like calculate all the other forces since they were in equilibrium initially. So you can say 2.5 to 2.9 is the result moment 7.3 Newton meter and 7.3 anti-clockwise. Question number 3. Power. Define power. Power is basically the work done over time. So why don't we just write that work done over time? Force F takes time t to move an object through displacement x at constant velocity v in the direction of the force. The work done by the force is W. Use the definition of power to show that power P transferred by the force is given by E is equal to Fp. So we know P is equal to work done over time, and work done basically force into uh, distance or displacement move by the object. And so if you like place it over here, you get P is equal to F into D over time. And now if you separate F, do that easily since they're multiplying, you get F into DOT. Now this is displacement over time, but we call it X. It is the same thing. So this becomes V. V is equal to distance over time, FP. A block is pulled up a slope by a wire attached to a motor, as shown in figure 3.1. The useful power output of the motor is 56 watts. Okay, so useful power output total. The block has a weight of 430 Newton and travels with constant velocity along the slope at an angle of 11 degrees to the horizontal. Assume that there are no resistive forces opposing the motion of the block. So it's basically a smooth slope. Calculate tension T in a wire. So we know that um, they've given us the power and they've given us the angle and the weight. So if you find the uh, like the component of weight over here, if you like draw a right angle triangle over here, then this becomes, and if it is rooted over here like this is a right angle. So this angle is 90 minus 11, and so this angle automatically becomes 11 degrees since it's a right angle. So basically, the component of its weight down the slope is going to be 430 to sine 11. Okay, horizontal. And you know that the useful power output of the motor is 56 watts. Okay, so it says that it is traveling with constant velocity. So it will only travel with constant velocity when it has no resultant force, right? There is no acceleration. So that's only possible when this force is equal to this force, and this force is basically tension, right? The tension will be equal to the component of the weight, which is 430 into sine 11, which we get is 82 Newton.
एक मिनट
Calculate the speed of the block. We, uh, we derived from in the first question, part A, P is equal to Fp. We have the power, 56 watts given in the question. and tension basically the driving force, right? So it's 82, and then we get is 0.68 meters per second. The rate of increase of gravitational potential energy of the block is equal to the useful power output of the motor. One of the reasons for this is that there is no work done against this stiff force. By considering the motion of the block, state another reason for this. The rate of increase of GPE. The GP over here is, let's say it's X, and then over here it becomes X plus something. We know what it's going to be, we can calculate this. We have the speed, useful power output of the motor, which is 56 watts. So it's basically saying that it's for every second it gains 56 joules of GPE. Since there is no work done against resistive forces. So now it's asking, by considering the motion of the block, state another reason for this. Okay. The only the only way that's possible is if all the power output is being converted into GPE. And that's essentially what's happening. Um, the energy can basically over here it can go into two forms. It can either go into GPE or it can go into kinetic energy. But since its velocity is constant throughout the journey, its kinetic energy is not changing. So basically, all the energy is going into the gravitational potential energy. So we can add that there is no change in kinetic energy. Hence, uh, the rate of change will be equal to gravitational potential energy. The motor has efficiency of 80%. Calculate the time taken for an input energy of 1.2 kilojoules to be supplied to the motor. We know it has a power of 56 watts. That's a useful power output. So total power output is going to be 80% of X equal to 56. So total power output we get 56 divided by 0.8 is equal to 70 watts. This is the total power output. And we also know that power is equal to energy over time. That's since work done. And work done is basically energy. So we can say energy over time. So they've asked for the time taken for input energy 0.2 kilojoules. So time becomes energy over power. Energy they're asking for 1.2 kilojoules, that's 1200 joules divided by power, which is 70. Hence we get 17 seconds. 20 divided by 7 is 17.14. But we need to take it to two significant figures. Okay, next question. A spring is suspended from a fixed point at one end and vertical force is applied to the other end, as shown in figure 4.1. The variation of the applied force F, the length L of the spring, is shown in figure 4.2. Determine the spring constant of the spring. You know that force is equal to spring constant into extension. So we know that the original length is 20 centimeter. So when we apply a force of 0, it's 20 centimeter, and when we apply a force of 30 Newton, the the original length of the spring, it becomes 60. So the extension over here is basically 40 centimeter. So this is the point where many make mistakes. They take extension as 60, but it's basically 60 minus 20, the original length. 30 Newton force gave us an extension of 40 centimeter. Okay, we get a 0.75. Sorry, 40 centimeter, right? 30 over 40 into 10 power negative 2. So we have to take it in uh, SI base units. That's basically 75. Determine the elastic potential energy in spring in the applied force F is 50 Newton. So basically, it has the basic formula of elastic potential energy is basically half into force into extension. Now over here we can change this according to our need. At 15 Newton, uh, the extension is 20. So we just take this formula. So half to 15 to you get 150. Sorry, 10 power negative 2. We don't make this mistakes. So it's basically joules. Okay. A horizontal string is stretched between two fixed points A and B. A vibrator is used to oscillate the string and produce an observable stationary wave. At one instant, the moving string is straight as shown in figure 5.1. The dots in the diagram represent the positions of the nodes on the string. These are basically nodes, points which do not move. Point P on the string is moving downwards. The wave on the string has a speed of 35 meters per second and a period of 0.04 seconds. Explain how the stationary wave is formed on the spring. Basically, stationary wave is formed when uh, two waves of the basically same type, same speed, same frequency travel in opposite directions, and their uh, amplitudes, their displacements meet, and that's when they form a wave. So basically, we say that waves on this string travel along the string and in opposite directions. So that's best done when it's the same wave and done on the same string along the string. Reflects at, let's say if it starts from over here, then it's going to reflect at B. So travel in opposite direction and they superpose. You can also interfere. On figure 5.1, sketch rank to show a possible position of the string a quarter of a cycle later than the position shown in the diagram. So basically, uh, it has speed. It has a speed of 0.04 seconds. So it's saying quarter of a cycle. That means after 0.01 second, what will be the possible? So we know if it's over here, then after 0.04 seconds, it's again going to come over here. So a quarter of a cycle, that means in 0.01 it goes here, then 0.02 again this point, 0.03 over here, and 0.04 again this point. So after a quarter of a cycle, the wave is going to be like this. The station is going to look like. Determine the horizontal distance from A to B. Okay. So basically, the wavelength of a stationary wave is similar to the of an original wave. This is the wavelength lambda, one wavelength. So in A to B there are two wavelengths and half a wavelength. Basically, there are 2.5 wavelengths or 3 over 2 lambda. And we can calculate lambda by this equation of waves. You know, f is basically 1 over time period, 1 over 0.04. So f we get is we can just do this over here. 35 speed into 1 over 0.04 is equal to lambda. Lambda we get is 1.4. 1.4, and now we just put this over here. AB is equal to 3 over 2, 2.4 equal to 3.5 millimeter. Particle on the string has zero displacement at time t is equal to 0. From time t is equal to 0 to time t is equal to 0.06. Particle moves through a total distance of 72 millimeters. Calculate the amplitude of the oscillation of the particle. Okay. So if there is displacement, if it moves, that means uh, it's saying the amplitude of the particle. So let's say the particle is at point P. So uh, in 0.06 seconds, it travels 72 millimeter. So we know that in 0.06 seconds, it takes one amplitude it travels one amplitude in 0.01 seconds, right? Since its time period is 0.04. So one, like one, two, one, two, three, four. That's what says basically going up, down, and up, down, up, down. So in 0.1, it gives us one amplitude. In 0.06, it's going to give us six amplitudes, right? So we just divide this by six. We should essentially get the answer. 72 divided by 6, which is 9 million. Sorry, no, it's not 9, it's 12. State Kirchhoff's first law. Kirchhoff's first law is basically regarding current. So total current, or you can say sum of current into a junction is equal to sum of current out of the junction. Basically, it's the law which we study in O levels, right? when there is like current I going over here, and then there is two wires going out from this point, then I2, let's say this is I2 and this is I3. Basically, I2 plus I3 is going to be equal to I1. Current is conserved. Assalamu alaikum warahmatullah. Let's continue again, inshallah. Sorry for the technical handwriting. The battery is connected to two resistors X and Y as shown. The resistance of resistor X is greater than the resistance of resistor Y. State and explain which resistor dissipates more power. So we know that current will flow in the path where there is less resistance. Think of it as like current as moving cars at traffic. So you would take your car to the place, the road, where there are less obstacles. Resistance is basically obstacles to the flow of current, right? So uh, power and both resistors will get same voltage since they are in parallel. So the only expression of power we can use is basically is equal to VI. So if they are both getting the same voltage, but current in Y will be more since it has less resistance. So Y dissipates more power as potential difference same and IY is more than IX. This could also be done with the expression P is equal to V square over R. If you substitute I is equal to V over R over here, since uh, the voltage is same, this will be the same in both, but resistance in Y is less, so it will have more power. The two resistors are made of wires that have the same length. Okay, both wires are made from metal of the same resistivity. State and explain which resistor is made of wire with larger cross-sectional area. You know that resistance is equal to resistivity into length over cross-sectional area. These two are constant, so we can say resistance is proportional to 1 over area. So resistance of Y is less than resistance of X, right? So if it is less resistance, and that means since it's inversely proportional, cross-sectional area will be greater. So uh, cross-sectional area Y be greater since just like try explain this over here. Uh, search for- Battery of EMF 9 volts and negligible internal resistance is connected in series with the light dependent resistor and a fixed resistor of resistance 1800 ohms as shown. A voltmeter is connected across a fixed resistor. The reading on the voltmeter is 5.4 volt. Calculate the current in this circuit. So V is equal to IR. V gets us 5.4 volts and its resistance is 1800. So the current we get is 3 into 10 power negative 3 rounded off to 7. Calculate the resistance RL of the LDR. Okay, so both resistors are in series. This is getting 5.4 volts, so that means RL will get 9 minus 5.4, which is 3.6 volts. And we figured out the current in the wire. So from there we can calculate the resistance. Voltage is 3.6. Current it gets is 10 to the power negative 3. So resistance is 1200 ohms. The intensity of the light illuminating the LDR increases by reference to the current in the circuit. State and explain the change, if any, to the voltmeter reading. Okay, this one is interesting. So we know that the graph of resistance against light intensity is basically an inverse graph. So as light intensity increases, the resistance decreases. And they've asked us to explain the change to the voltmeter reading. So if its resistance is decreasing, that means the voltage it gets is also going to decrease. So its voltage is going to increase. You can also say that since its resistance is decreasing, the overall resistance of the circuit is decreasing. So that means the current in the whole circuit will increase. So the uh, that means that it will get more voltage. That's light intensity. You can say the resistance increases. So sorry, resistance decreases. Not bad. So current increases, hence voltmeter reading increases. Okay. Question 7. An unstable nucleus A ZX, group one number, atomic number, decays by emitting a negative beta particle. This is basically an electron. Determined quantitatively the changes any in A and C1X decay. So uh, the production of electron, it happens when a neutron, it decays into a proton. This emits electron and it emits an antineutrino. See, this is the equation which you have to do. The change in A, there will be no change in A, no change since both are nucleons. Basically, one nucleon converted into another. But change in Z, it will be +1 since there is an extra proton. In addition to the negative particle, when the lepton is emitted to the decay, state the name of the lepton. This is the another lepton in the neutrino. These are basically fundamental particles, leptons. A particle P is composed, okay, of an up quark and a down quark, any down quark. Calculate the charge Q of particle P in terms of E, with E is elementary charge. So you're working. So easiest way to remember charges is basically cut. It's a short form of charm up top. In all of these have a charge of positive 2 or 3 elementary charge. And all the other uh, quarks which we have down, bottom, range, these are the only left like in our syllabus. So they'll have a charge of -103. So an up plus anti down, that means it's a +2 or 3 plus anti down, and down has negative, so anti down the positive charge. The solar charge will be 1. elementary charge. Particle B belongs to two classes of particles. Say the names of these two classes. So in so basically the bigger class is hadrons, and in hadrons we have baryons and mesons. Baryons are basically proton and neutron, and mesons are basically those which made up of a quark and an antiquark. Like we have a pion, kapas. So two classes will be hadrons, and the other class will be mesons. This fundamental nuclear physics is mostly memorization. Hopefully, this paper was not too difficult to solve.